Hello everybody, this is Mr. McNair, and this is the final review portion for Chapter 6. Here's the answers to 12 through 26. You could pause it if you need to. And here's the answers for 27 through 29. Alright, let's go ahead and go through a couple choice problems here. So, first one here says evaluate each expression for the given values of the variables. So, first thing that I want to notice in this problem is this a to the 0. We know that any number to the 0 power besides 0 is 1, excuse me. Any number to the 0 power is 1. So this is really like having 1 times b squared. And 1 times b squared is just going to be b squared, right? So we really don't even need that there at all. That kind of just cancels each other out, cancels it out. So we have 14 minus b squared, and b we know is 4. So that's 4 squared to the negative third. We know that 4 squared is equal to 16. Okay, and then we know 14 minus 16 is negative 2. And then once again, we're going to simplify here. Now, the way that you get rid of a negative exponent is by taking the reciprocal. You flip it. You change its position. Okay? So right now we have all of this in the numerator. So this is all going to go to the denominator, and the exponent will become positive. So that's going to become 1 over negative 2 now to the positive third. Now remember, when you flip something based on the exponent is the value that changes, not the base. All right? So here, notice we had a negative 2 as the base, and the base was still negative 2. The only thing that changed was the exponent of negative 3. That became positive 3. All right, now let's go ahead and simplify some more. We know that negative 2 to the third power is negative 8. So our answer is negative 1/8. All right, number 15, we're simplifying this one. First thing that I would notice here also is that you have 3 things here that have negative exponents. This base, and this base. So that's pretty much the whole thing, right? So what I would suggest you do is go ahead and get rid of these negative exponents. Okay, and we can get rid of a negative exponent by, once again, taking its reciprocal, changing its position. All right, so this is what's on the top. I'm going to move that base to the bottom. Oops, that's to the third. And the exponent is going to become positive. And then this 2 to the negative fourth and the x to the negative 10th, those are going to go to the top, and the exponents are going to become positive. Okay, let's simplify some more. 2 to the 4th power we know is 16. And then we're just going to bring down that x to the 10th. And this squared out here, we're going to distribute it into the parentheses, into its base. So 8 to the 2nd power is 64. And when you raise a power to another power, you multiply the exponents together. So that's going to be x to the 6. We know that 16 over 64, that fraction here, this reduces to 1/4. Okay, and then x to the 10th divided by x to the 6th. Whenever you multiply powers together, you add the exponents. Whenever you divide powers, you subtract them. So 10 minus 6 is 4. So that's going to be x to the 4th. And you always start it off in the numerator. Okay, one thing, and that problem is done. One thing that you would probably recognize is that this 1 is not necessarily, it doesn't really need to be there, because 1 times anything is itself. So our answer, x to the 4th over 4. Next, this problem. We have this 2 here on the outside that needs to be distributed into everything in its base. Okay, so 5 to the 2nd power, that's 25. That'll be x to the 2nd, y to the 2nd. And then still to the bottom, to the denominator, we have 8 to the 2nd power, which is 64, x to the negative 2, and we know it's negative 2 because, once again, when you're raising a power to a power, you multiply the exponents. So negative 1 times 2 is negative 2. All right, and then the same thing here with that y to the 4th, because we multiply those together. All right, let's go ahead and bring down the other expression, 26y cubed over 5x squared y to the 5th. Now, whenever you multiply fractions, you always multiply straight across. So that's what I'm going to suggest that we do here. 25 times 26, that equals 650. X squared times, oh, well, there's no x over here, so we're just going to bring that over. That's just going to be x squared. And then y squared times y cubed. Whenever you multiply powers with the same base, you add the exponent. So that's going to be y to the fifth. All right, on the bottom, here we have 64 times 5. 64 times 5 is 320. X to the negative second times x to the positive second. Once again, we add those exponents, and we get x to the 0. Anything to the 0 power is 1. So that actually, these cancel each other out, because 1 times anything is itself. All right, and then here we have y to the fourth times y to the fifth. Once again, we add those exponents, making that y to the ninth. Now, we're going to go ahead and reduce this. So 650 over 320, that reduces to 65 over 32, because those are both divisible by 10. This x squared that we have here, well, there's nothing to divide it with in the denominator, so we're just going to bring down the x squared. And this y to the fifth over y to the ninth. Once again, we subtract the exponents, and we get y to the negative fourth. And it always, always, always starts in the numerator. Now, the issue is that we have this number, this base, that has a negative exponent. And you're not allowed to leave expressions with negative exponents in them. The way we get rid of that is by moving its position again. So the 65 doesn't have a negative exponent. That's going to stay where it is. Same with the x squared. Same with the 32. They all stay in position. This y to the negative fourth, that's the only thing that moves, because that's the only thing with a negative exponent. So it goes down to the denominator, and the exponent becomes positive. And there we go. This is our answer. All right. Next, here we're simplifying the expression. Here we have an index of 5, and you should know that whenever you have an index of 5, you can rewrite it to have a power of 1/5. All right, and you can take that 1/5 and distribute it into the parentheses, just like we did in the previous problems. So once again, when you raise a power to a power, you multiply them together. 5 times 1/5, that's just 1, so that's going to be 3 to the first, or just 3. 10 times 1/5, well, that's going to be 2, so that's t squared. All right. Here, add or subtract. Well, this problem, we're going to add, because there's an addition sign between them. Whenever you're adding polynomials, you just add the like terms. So we have like terms here of negative 4b cubed and positive 6b cubed. So that adds up to be 2b cubed. And then we also have like terms of 2b squared and 8b squared. And that adds up to 10b squared. Okay? Remember, when you add like terms, the terms don't change. Notice that this is still a 3. The term still didn't change. Notice that these are still 2's. Okay? 5 apples plus 6 apples is 11 apples, not 11 apples squared. All right. Now, this one we have a minus sign. This is a subtraction problem. When you're dealing with the subtraction, just like we know that 3 minus 7 is the same thing as 3 plus negative 7, and this minus sign belongs to that 7, and that's why we have this here. It's the same concept with this polynomial. This minus sign belongs to all of that in there. So this 5x cubed, we're just going to bring it down. That minus sign now is going to distribute, making that a minus 6x cubed, a positive 5x squared, and a positive 3x. Now once again, we're just going to add like terms. 5x cubed minus 6x cubed, that's negative 1x cubed. So those are gone. I like to cross them out so I know that I've already dealt with those. Positive 2x squared and positive 5x squared, that's positive 7x squared. Those are gone. We have this 3x here that doesn't have anything that's like terms with it, so we'll cancel that out. And then left, we have this positive 8. And there we go. We've added all the like terms. Here, we're multiplying. When you have something on the outside like this, all we're going to do is distribute it into the parentheses. Okay, so let's distribute. Negative 5 times this here, well, this first term, there's no coefficient on that, so we're just going to bring the negative 5. R times r squared, that's r to the third power. And then we're just going to bring in that s. Then we distribute over here to that negative 6. Negative 5 times negative 6 is positive 30. and then we're just going to bring down the r. Okay? Here we have 3x squared minus 7 all to the second power. Now this one is kind of deceiving because a lot of people try to distribute that exponent of 2 on the outside, but you can't do that. Okay? 3x squared minus 7 all to the second power is the same thing as 3x squared minus 7 times 3x squared minus 7. And from there, we FOIL or distribute. This 3x squared has to distribute to both of those, or do your first and your outer. So 3x squared times 3x squared is 9x to the fourth. Because remember, when you multiply powers, you add the exponents. 3x squared times negative 7, that's negative 21x squared. And then we're going to also distribute this negative 7 here. Do your inner and your last. So negative 7 times 3x squared is negative 21x squared. And negative 7 times negative 7 is positive 49. Now from there, all we're going to do is add like terms. Nothing like terms with that, so we just bring it down. These two, however, are like terms, and that adds up to negative 42x squared. So those are gone, and then we'll bring down that positive 49 that's left. And that's our answer. All right, that's pretty much it for Chapter 6. Good luck studying for your final.